today about something that we have a lot of here on Timscovery. You know we have a lot of? We have a lot of? You know we have a lot of? We have a lot of? There are three types of energy: potential energy, kinetic energy, and spring potential energy. The first kind of energy is kinetic energy, which is the energy of an object that's in motion. That's motion! The equation for kinetic energy is 1/2 mass times velocity squared. Potential energy is how much energy something has by the relationship it has with the distance from the Earth. This equation is U equals mgh. Spring potential energy is how much energy is stored in a mechanical system, like a bowstring or a spring. Kinetic and potential energy have a great relationship with one another. Because of the law of conservation of energy, which states that the amount of energy in a system can't change, there is a relationship between potential and kinetic energy that allows you to calculate the velocity of something, because all of its potential energy when falling must be turned into kinetic energy. We can demonstrate this relationship using the magic racetrack of science! We know that this height is 2 meters high, and knowing that, we can convert the potential energy it has into kinetic energy, and therefore we can calculate the velocity it will have.
To find the velocity of the car, we set the potential energy of the car, which is mass times height times gravity, equal to the kinetic energy, which is 1/2 mass times velocity squared. Then all we have to do is solve the equation for velocity.
The last kind of potential energy is spring potential energy. And now normally you'd use a spring for this, but Timscovery is too poor to afford any springs, and we just happen to use whatever's lying around, which in this case is a bow and arrow, which still has a spring to it, so therefore we can use spring potential energy. The equation for spring potential energy is 1/2 kx squared, where x represents the displacement of the spring and k represents the spring constant. We can solve for the spring constant of a spring by putting an object on the spring, displacing the spring, and then releasing it, giving the object the kinetic energy that was in the potential energy of the spring. And then we can solve the equations together to solve for the spring constant. So we got our spring here with our object, and we're going to displace the spring, which is sitting at 24 centimeters, and we're going to displace it to 32 centimeters, which gives it a displacement of 8 centimeters. And now we're going to shoot it at a level trajectory, and we're going to measure how far it goes, and we're going to use kinematics to solve for how long it falls to the floor, and then we can solve for time, and then we can solve the entire equation for what the spring constant is.
Problems like these are very popular in physics tests because it requires us to use multiple steps using different aspects of physics. First, we must figure out how long it took the arrow to fall to the ground. This is done using the equation distance equals starting distance plus initial velocity plus acceleration times time squared, and then calculating for time. Then we place the distance traveled over the time and then set it equal to x distance over 1 second to get a velocity. Lastly, we set the equation for spring potential energy equal to kinetic energy and then solve for the spring constant using the velocity we have calculated.
I want to thank you for watching this video about energy. I need to get the rest of my energy out by working out, but for now, you can go and solve lots of energy equations with everything you've learned in this video. Thanks for watching!